Yeah. All right, so remember, what's our procedure going to be here with this? You guys remember? Here's what we're going to have to do. You're going to need the LCM of 8, 5, and what? 10. You guys okay with that? Okay, so we just got through going over how to get the LCM. We'll do that again because, you know, it might be helpful. So you got 8, 5, 10 here. Let's go over our process that we did earlier and last week. So give me a prime that divides at least 2 of these numbers without a remainder. Right? 2. Okay, 2 goes into 8 how many times? 4. Does 2 go into 5? So just bring it down. 2 goes into 10 how many times? 5. Good. And now we repeat the process. So we need a prime number that goes into at least 2 of these. 5. Good. 5 doesn't go into 4. Is that right? So we bring the 4 down. 5 goes into 5 how many times? The quotient is 1. 5 goes into 5 once. The quotient is 1. And so we can't repeat the process because our prime has to go into 2 or more of these numbers, right? So 2 goes into 4 only once. It doesn't go in to any other number here. And 1's not a prime. So remember, that means we just multiply these numbers. This is our LCM. So 2 times 5 times 4 times 1 times 1, what's that LCM going to give us? Yeah, it's 40. So this is what we're going to use here. Okay, LCM is 40. All right, so let me bring this down here. We have 5/8 minus 3/5 is x over 10. Now, what do we say we had to do? What's in our procedure? Multiply both sides by the LCM of 40 here. Okay? Now, even though we can actually, on this side here, subtract our fractions that are not like, we can solve it that way. We know how to do that. I'm just showing you this new procedure that is going to work for all the other equations, including these, which is what we have on the board, right? So remember what we want to do here. Here's how we really handle this. We find the LCM. This is our first step. We got that already. And then we multiply both sides by the what? By the LCM. Left side and right side. And if you notice, on my left, I actually have a difference here, don't I? So that means I have to distribute my multiplication on the left side. On the right side, I don't have to do that. So we're going to get now that 40 now gets multiplied to 5/8. And then that 40 gets multiplied to the 3/5. And then that 40 gets multiplied to x. I'm going to put it on the other side, though, because the order in which you multiply doesn't matter. And really, now we're going to see why we need the LCM, right? So here's our LCM again, 40, 40, and 40. Why do you think that's a benefit for us here? Do you guys know? Because 8 goes into 5 how many times? Or 40 how many times? I gave you the answer. 5 times. 5 goes into 40 how many times? 8. 10 goes into 40 how many times? 4. So you end up with 5 times 5 minus 8 times 3 is really 4x here. And 5 times 5 is 25 minus, what's 8 times 3? Is that 24? And that's 4x. And so, ladies and gentlemen, we end up with 4x going to equal, what's 25 minus 24? Is that 1? Okay. How do we solve this equation? Because what you guys see now, I'm going to say to you guys, this is called a linear equation here. All right? Linear equation. That means the highest power of your variable for x is 1. How do you solve this? Do you guys know? Divide both sides by 4, is that right? Yeah. And your 4's cancel. We get x is 1/4. So ladies and gentlemen, this is how you solve what's called a rational equation. This is your first type. And again, the procedure is simply find the LCM, multiply both sides by the LCM, and then ultimately down here at the very end, you get to solve a nice equation here. And this equation happened to be linear. Sometimes the equation you get is actually quadratic. Sometimes it's linear. So you guys know how to solve both of those, quadratics and linear. Okay? Anybody have any questions on this one here? No? Is that pretty straightforward? Do you guys actually see why you care about the LCM? Okay, let's do the next one here. The next one is 3/5 plus 1/8. And then this equals what here? 1/x. So remember, you're going to start off by finding the LCM of what? Yeah, of the denominators, 5, 8, and x. So we could do this a couple of ways here, all right? Remember, we can start off by saying 5, 8, x again. Is that right? Now, what do we need here? We need a prime. Is that true? That divides what? 2 or more, at least 2 of these numbers. So we're going to remark again our primes so that people who haven't been here can recall. What are our primes again? List the primes, right? Smallest prime is the first, right? First prime there, and it's the only even prime. It's what? 2. One's not prime. What else? 3, 5, 7, not 9, but 11, 13, not 15, but what? 17, 19, not 21, but what? 23, and this list goes on forever. Is that right? Now, this is when we have numbers. What about the variables, though? Remember the variables? We said x, y, anything that's not factorable, right? Because that's what prime really means again. It means not factorable. So you can have variables, you can have terms like x plus 3, x minus 7, y plus 5, x squared plus x plus 1. You can have 3x minus 2, 2x plus 3. Okay, you could even have x squared plus 4. All of these, again, are not factorable. So these are all considered primes. Okay. So we discussed all this already. We need a prime that goes into at least 2 of these. And what do we find? Is there any primes that go into at least 2? No. No. So what does that mean here? It means you're done. It means the LCM will be 5 times 8 times x, or my LCM is really what? 40x. Good. So what do we do with that LCM of 40x again? Right? We go back to the original equation. And we're going to multiply both sides now by the LCM. The LCM is 40x. The other side, you get what? 40x. And on this side, yes, we have to distribute. So when we distribute, you notice we get 40x times 3 over 5 plus 40x over 8 is 40x over x. So again, the benefit of using the LCM will always be what you guys see now, right? You might say, what do I see? Well, 5 will go into the LCM of 40x. 5 particularly goes into 40. How many times? 8. 8 goes into 40 how many times? 5x and x cancel. So let's see, what kind of equation do we have next here, or left? This is 8x times 3. Go back here. 8x times 3. You guys okay with that? 5x. That's just 40. So this will be 24x plus 5x equals 40 now. What type of equation is this? Yep, this is a linear equation, ladies and gentlemen. Now, what do you do with linear equations? You guys know how to solve them. Is that right? Yeah. Combine your like terms. And what's 24x plus 5x? Isn't that what? That's going to be 29x, and that equals what? 40. Divide both sides now by 29. This cancels. And what do you got? X will be what? 40 over what? Over 29. And can I simplify this fraction, by the way? Nope. 29 is prime, isn't it? Yes. And this is your final answer. So 40 over 29 is the solution. And then this is how we do what? This is how we solve rational equations. That's your procedure. Remember, the procedure is this. Determine your LCM. Multiply both sides of your equation by the LCM. And then solve the remaining equation for x. There it is. Okay. Let's try another one here. Number 3. X plus 3 over x is -4. All right, you guys okay with that? So you might say to me, what? This first term, just x, we can write as a rational, a fraction. Okay? And so again, you say, do I need the LCM of my denominators? 1, x, and oh, what about this one? This is also really what? 1, is that right? So I need the LCM of really just 1 and x. So let's go through that procedure again. Give me a prime that goes into both of these numbers. What do you guys notice? Is there a prime that goes into both, divides both with a 0 remainder? The answer is no good. So what's my LCM? 1 times x, or the LCM is just really what? X. Okay. Multiply both sides of my equation. X plus 3 over x is -4. Multiply both sides by the LCM, which is just what? X. What do? You distribute. X times x is what? X squared. Maybe you want to do every detail. How's that? Let's do every detail. X times x plus x times 3 over x. You guys okay with that? And that's negative. That's just -4x. So let's simplify what we have here. Okay? X's cancel. What do you have left? X squared plus 3 equals -4x. Do you guys know what kind of equation is this? Yep. This is a quadratic equation. How do you know? Highest power of your variable x is 2. That makes this a quadratic. Okay? So if you guys recall, how do you guys solve quadratics though? One of the sides has to equal 0. Is that right? So what I'm going to do now is I'm going to add that 4x to both sides here. So you get x squared plus 4x plus 3 now equals 0. And there's your quadratic. Okay? What's your first line of defense when you have to solve a quadratic? You guys know? What do you guys use? Hopefully we can what? Factor and use what we call the zero product what? Rule. Okay, factor and use the zero product rule. Anybody remember what you guys do? Some of you guys, we can either use what's called the chicken soup recipe, or those who are directly out of high school, you say, no, Mr. Judge, I want to do what? My product here has to be 3. My sum has to be what? 4. Remember this? So product is 3. Sum is 4. Right? Product has to be that number. Sum has to be this number. Is that true? Okay, what two numbers satisfy this requirement? 3 and 1. Let's double check. Is 3 times 1 3? Okay, what's 3 plus 1? There it is. So we're already going to have in our answer x, x. This is now plus 3 and plus 1. These numbers go here and where? There. So this is factoring. Okay, now the zero product rule. Bring out your t. X plus 3 is 0. What else? X plus 1 is 0. So you're going to have to do what? Subtract 3, subtract 1, and what do you get as answers? X is negative 3. X is negative what? 1. Now, let's check to see whether these are really solutions here. Okay, so remember, what does it mean to be a solution? Let's note. The original equation we have, x plus 3 over x would be negative 4. I automatically want to remind you guys here that x could never equal 0 here because you could never divide by 0, right? All right, well, they're saying here x is actually negative 3. So if I plug in negative 3 here, what do we get? Negative 3 plus 3 divided by negative 3 should equal negative 4. Negative 3 minus 1 is in fact what? Negative 4. So negative 3 is a solution here. Good. What if we plug in now the other value? We plug in a negative 1. Now we get negative 1 plus 3 over negative 1 should be negative 4. So negative 1 minus 3 is in fact negative 4. So that's what we mean by having a solution. And sometimes if you look in algebra books, you might see answers in set notation. So you guys know. Negative 3, negative 1, we have a what? A solution. So I just want to point that out. That's the same as saying here, so you guys know, x is negative 3, x is negative 1. Okay, this is our solution here. So what do you think? Is it good to invest in finding the LCM? Right? So we have x over 7 now minus 7 over x is 0 here. So we need the LCM of your denominators, 7 and x. We have to find that. Let's go through our procedure again. Give me a prime that divides two of these terms here with a 0 remainder. What do you guys notice again? Is there a prime that can go? Remember, 1's not a prime. I'm not saying you said that, but is there a prime that does that? That goes into what? Is there a prime that goes into both of these terms? The answer is no. What does that actually mean now? What's your LCM? 7x. Just multiply the terms. That's what we need. So as we have x over 7 minus 7 over x is 0, multiply the right side by 7x and the what? The left side by 7x. So I get 7x times x over 7 minus 7x times 7 over x. Now what's 0 times anything again? That's what? That's 0. Is that true? Okay. So when you multiply both sides of your equation, which is the same as really just multiplying every term by the what? By the LCM, because you distribute a sum and a difference, right? So every term gets multiplied by that LCM. What will always happen if you got the correct LCM is that you will have some nice cancellation here. So now we end up with x times x, which is x squared, minus what number? 49 equals what? 0. So can you guys solve this here? What do you guys think? You have a couple of ways you can solve this, right? Yes?
Instead of the equal 0 is 7x, right?
Well, what's 7x times 0 here? Here's the question.
Oh,
Yeah, times 0 is going to be what? 0.
0.
Yeah. So there's two ways to solve this here. One is by factoring, is that right? X plus 7, x minus 7, and that equals 0. Zero product rule says x plus 7 is 0. X minus 7 is 0. Right? And what do you do here? You can subtract your 7 from both sides, and you get now an answer. Add 7 to both sides, and we get the value that x is what? Negative 7. We get the value that x is positive 7. Okay? Now, this is from beginning algebra here. You see the same kind of question in intermediate algebra and college algebra. So if you guys remember, what you can do is add that 49 from both sides here, and you end up with x squared is 49. Is that right? So at this point, we can use the square root formula. So x will be plus or minus square root of 49, or we say x is plus or minus, what's this value? 7. So you have two solutions, positive 7 and what? Negative 7. Okay, so you have two ways to do that. One is by factoring and using the zero product rule. This is why factoring is actually a very useful tool for us. You notice that this here is the difference of two what? Perfect squares. So you use the difference of perfect squares factoring formula and the zero product rule. Okay. So aren't you guys glad you worked on the LCM now? Yeah. So let's notice the next one here. We got what? 3 over x. Is that minus what? Sorry, equals 4 over x minus, what's this? 1 over 5. So I essentially need here the what? The LCM of x, x, and 5. Now, if you're duplicating terms, when we find the LCM, we say x, x, and 5, we can do it this way. Or we could just get rid of one of these. Does anybody know why? Isn't that just the same term? So the LCM of x, x, and 5 is just like finding the LCM of x and 5. Maybe you don't believe me. Let's say you don't. It's not uncommon that students don't believe me, right? Do you think we could still follow the process? Give me a what? A term that goes into at least 2. Give me a prime that go. Yeah, you're gonna say x goes into both. Okay, x goes into the first one how many times? 1. X goes into the second one. 1. X doesn't go into the third. Let's bring down the 5. Can you find a prime that goes into both? Nope. That means you're what? Done. So that your LCM now will be x times 1 times 1 times 5. We just multiply these what? These terms. Okay? And what do you guys get? LCM is going to be what? 5x. Is that right? Now, notice this though. What if you said, can I just use one of those x's since it's duplicated? And I'll say yes. When you go through your process, we need a prime that goes into both of these terms, and then you notice that what? There are none, so then that LCM really in fact turns out to be what? 5 times x, is that right? Anyway, just want to point that out to you guys. Now, what's the next step again here? Yeah, multiply LCM on both sides here, so. And let me erase this so I have some space. You guys okay with that? Okay, we know the LCM is what? 5x. So I'm going to multiply my left side. Oops. Multiply the left by what? 5x. Multiply the right by what? 5x. Don't forget on the right side you distribute. So I have 5x times 3 over x. 5x times 4 over x. Minus that 5x over 5. And yes, 5x times 1. Okay, so you're going to distribute because you have subtraction here. You're going to distribute this multiplication. So every term gets multiplied by what? By the 5x. Okay, that's really what's happening. Every term gets multiplied by the LCM. So now, let's get rid of this. Let's do our cancellation. X and x is gone, is that right? X and x is gone, and then 5 and 5 is gone. What do you have left? 15 equals 20 minus what? X. Be very careful to see what's left. When you cancel, sometimes it's hard to see. You got a 5 here, you got a 3 there. Is that true? You got a 5 here, you got a 4 there. Here we have an x. So double check to see whether we're okay with that. So now I get 15 equals 20 minus x. What kind of equation is this? Do you guys know? This is a nice what? Linear equation. So we can solve this. We can subtract 20 from both sides. We end up with negative 5 equals negative x. And what do you guys do now with this? You could divide both sides by what? You could do that. And then you get what? What's a negative over a negative? So we have negative over a negative is a positive again. Negative over a negative is a positive. We get 5 is x, or we can simply say x is what? 5, and you are done. Okay? Now, should we check this and double check to see if that's really happening? Plug in what here? 5, plug in 5, is that right? So that means 3/5 is the same as what? 4/5 minus 1/5. And that looks like that's true. Okay. Let's try number 6 here. X minus 4 over x plus 6 equals what? 1/3. Is that right? Now, we're going to need, what do we need again? The LCM of your denominators. Is that true? So I need the LCM of x plus 6 and 3. Remember, this is just like what we discussed. Isn't x plus 6 prime? Let's go back here. You guys remember this? You got a prime and you got another prime. Both of these are not factorable. So remember what we talked about. If I change this to maybe a w, because it's prime just like x plus 6, what's the LCM going to be? Remember how we get the LCM here? Yeah, it's going to be what? It's going to be the product, isn't it? So you can say it's going to be that w times 3 because we don't have a prime term that divides both. So your LCM will be w times 3 here, or we can say it is what? X plus 6 times 3. Or the LCM can be written as 3 times what? X plus 6. Okay, you guys remember this one? See, I told you it was going to show up. Oops. Undo. That was going to show up. Okay. So what do we do with this again? We multiply what? The left side and your right side by the LCM of 3 times x plus 6. 3 times x plus 6. So if you guys remember in our warm-up, yes, it's true that 3 times x plus 6 is 3x plus 18. Remember we did this one? See, I gave you guys that for your warm-up because I knew we were going to be using it today. All right, you guys remember this one? Yeah. So what my recommendation is, because you're multiplying both sides by the LCM, don't actually use the 3x plus 18. Leave it as 3 times x plus 6 in parentheses here. Because now when we multiply, let's see what we have here. So you guys know, we get what? 3 x plus 6 times x minus 4, everything over x plus 6, because you're multiplying over here. This is the one you just did. That needs to be in a parentheses, like we put here. This is my denominator, and it's down here too. All right, you guys okay with that? So we multiplied. Now on the other side, though, you get what? 3 times x plus 6 over what number? Over 3. Because we're multiplying again. Okay. Now, what did I say earlier here? What's going to happen if, in fact, you found the right LCM? What always will happen? You get this cancellation. Remember this? X plus 6 is gone. Is anything else gone on the left? No. On the right, a 3's gone. So what you have left now will be, let's see what we have left. 3 times x minus 4 becomes x plus what? 6. What kind of equation is this, by the way? This is a linear what? Equation. How do you solve linear equations? Right, remember, you're going to have to distribute here. 3x minus 12 gives you x plus 6. What happens now again? Solve for x. Subtract your x from both sides, and what do you end up with? 2x minus 12 becomes what? 6. Add 12 to both sides here, and you end up with what? 2x equals what? 18. Divide both sides now by what number? 2. What happens with the value of x? X is what? 9. This here is your what? This is your solution. Now, x is 9. If we go back here again, 9 for x, 9 for x. Let's double check. Is it 9 minus 4 going to be 5? So we get a 5 in the numerator, and then 9 plus 6 is what? 15. Is that equal to 1/3? The answer is yes. Just to kind of double check here. Okay. Okay, good. Good. All right. Let's try number 7 here. What do you guys get for number 7 here? We're going to do a few more and then take a break, but what do you guys get for number 7? Right? It's covered up here, so. Yeah, x plus 8 over x is negative 9. Okay. X plus 8 over x, that equals what?
Negative 9.
Negative 9. Is that true? So you may look at this and say, oh, okay, these whole numbers are whole terms. We divide by 1 because we need the LCM of the denominators, 1, x, and 1. Is that true? What's the LCM going to be? It's going to be x. Good. You say, how do I know for certain? Okay. Go through the procedure. Give me a prime number or prime term that divides both. The answer is what? There is none. So just multiply what you have here. That LCM will be 1 times x. You guys know this already. So since we have the equation x plus 8 over x is negative 9, we're going to multiply both sides by what? The LCM of x here. So let's multiply both of those sides by x. Distribute. What do you end up getting? X squared plus. Now let's do every term, every sort of detail here for you guys. Right, every term gets multiplied. So we got x times x plus maybe 8x over x, right? That's minus 9x. X squared plus 8 is negative 9x. What kind of equation is this? This is a what? That nice quadratic equation? So how do you guys solve quadratics again? Yep, we need one side to equal 0. So you get x squared plus 9x plus 8 equals what? 0. What do we do now with this? You what? You factor, is that right? So didn't we do a lot of work with factoring, by the way? Say yes. The product is 8. And the sum is what? 9. So I need two numbers multiplied together whose product is 8, whose sum is 9, because what's the story? We're factoring. So what are the numbers? 8 and 1. 8, 1. Okay, so this is plus 8, plus 1. Is that true? Okay. 0 product rule. X plus 8 is 0. X plus 1 is 0. What do? Subtract 8. Subtract 1. What do you end up getting here? X is negative 8. What's the other one? X is what? And you're what? Done. Okay, you guys okay with that? So they put the solutions in solution set notation at times, so there you guys go. Okay. You can check it. So this is number what? 7. What was number 8?
1 over x plus 3.
1 over x plus 3 equals?
4 over x minus 1.
4 over x minus 1. Okay, what else?
That's it.
That's it?
Yeah.
Okay. Let's write this a little better. 4 over x minus 1. Okay, now the procedure here, and yes, if you guys notice this, I want to also bring up another observation for you. Let's note. You want to know what this is also known as? This is a what? This is a proportion. Is that true? Okay, equal ratios is called a proportion. So, from beginning algebra, you can solve these by simply doing what? Do you guys know? What's this known as? Let me show this to you. This is called what? Cross multiplication. Is that true? So I can cross multiply here. So this statement is equivalent to AD equals BC from beginning algebra. Now, how this helps you is we can now say this is 1 times what? X minus 1 is 4 times x plus 3 because we use cross multiplication here. Okay, is that okay? So this is what we actually did here. And now if we, do some simplification, 1 times anything is itself, so that's simply x minus 1. And then I'm going to distribute my multiplication with 4. I get 4x plus what? 12. This is a linear what? Equation. And how do you solve linear equations? Right, you solve them in your sleep, right? Sorry. Subtract what? 4x from both sides, and you now have negative 3x minus 1 becomes 12. What do you do with this as well? Add 1, and you end up with what? Negative 3x is 13. You're going to divide both sides now by negative 3. Cancel. You get x is negative what? 13/3. So this is how we solve number what? Number 8. Number 9. X over 8 minus x over 12. What does that equal?
1 over 8.
Is that 1 over 8? Okay. So again, we're going to use the LCM of the what? Of the denominators. Since I have an 8 duplicated, do I have to write it down 2 times? The answer is no. 1 is appropriate. Is okay? Are you guys okay with that? So give me a prime that goes into both of these numbers. 2. Good. 2 goes into 8 how many times? 2 goes into 12 how many times? Good. Repeat the process. 2 goes into 4 how many times? 2 goes into 6 how many times? Oops, sorry. This is 2 and this is 3. Is that true? Can you give me a prime that goes into both of these numbers? No. So what do you guys have here then? What's your LCM? LCM will be what? 2 times 2 times 2 times 3, or my LCM will be what here? 8 times 3. What is the LCM going to be now? 24. So we're going to do what with that 24 here? Multiply every term, both sides of your equation, x over 8 minus x over 12 is 1 over 8. Multiply both sides by that 24. Is that right? So we'll end up with 24x over 8. Oops. Don't do what I just did. Multiply what? Both sides you have to distribute. So this 24 gets multiplied to both terms because I have a difference here. So that'll be 24x over what? 12. And this is 24 over 8. So let me show you guys here how that 24 is multiplied to every term. Now, if you did everything right, what's the story here? What could you do? Or what will happen? Do you guys know? 8 goes into 24 3 times. 12 goes into 24 what? Twice. 8 goes into 24 3 times. So be careful here and to check to see what's left. 3 and x. 2 and what? X. And then just a 3. So this is where you could really make a mistake when you do all your cancellation here. So we have here 3x in gray minus what? 2x will be the number 3. And now you have a nice linear equation. And 3x minus 2x is simply what? X. X equals what? 3. Here's your solution. It's number 9. So let's keep going here. What's number 10?
X plus 2 over 5
Okay, x plus 2 over 5.
minus 1.
Minus 1, what does that equal?
X minus 2 over 4.
X minus 2 over 4. Okay. What do I need? The LCM of 5 and what? 4. Is that true? Now, can I put this over 1 and say I need to find the LCM of 1, 1, 5, and 4? The answer is yes, but do I really need to? No. Good. So I need the LCM of 5 and 4, so let's go through our format, right? Okay, give me a prime that goes into both of these terms.
No.
There is none. What does that mean? That means you're done. What's the LCM?
20.
Yeah, 5 times 4. LCM is actually 20. There you guys go. So we're going to multiply again what? Both sides by the LCM, which really means we're multiplying every term by your LCM. So you multiply the right by 20, the left by 20. Don't forget to distribute here. Okay, we're going to distribute here. Okay, 20 times, let's be careful. Put that x plus 2 in parentheses over the 5. And then this is now 20 times 1, which is just 20. Be careful over here too. You got x minus 2 in parentheses times that 20. Divided by the 4. Make sure that 20 is multiplied to every term. Okay, you guys okay with that one? And then now you might say, what happens with the rest of this? Well, if we've done this correctly, what's going to happen again? We're going to do what? Yeah, when we simplify, we're going to get nice whole numbers. In other words, your fractions, the denominator goes away with everything here. So 5 goes into 20 how many times? 4. This is just 20 here. 4 goes into 20 how many times? 5. So let's be careful. 4, x plus 2 is left here. We already have the 20 here. X minus 2 and 5 is left on the right side. So 4 times what? X plus 2. Minus that 20 on the left side is 5 times what? X minus 2. So, ladies and gentlemen, this is a nice linear equation again. Okay, I want to let you guys know this is a linear equation. So how you solve these again is by using your distributive property. So you end up with the following. 4x plus 8 minus 20 becomes 5x minus 10. 4x minus 12 becomes 5x minus 10. What do you guys do with this now? Subtract 5x. Negative x minus 12 is that negative 10? Okay. You're going to add your what? 12 to both sides, and what do you get here? Negative x is positive 2, is that right? Double check, because I'm not really awake. And you get now what here for x? X is negative 2. Good. Here's a solution set here. Good. Okay. Let's try number 11 now here. What do you guys get for 11? 3 over x plus 7, is that right? What does that equal? Over x plus? Ah, this is an interesting thing. We could do it two ways again. We can actually look at this as a proportion in case you guys didn't know. But I want you guys to consider something like this. A couple of things we can do. Let's note a few things. Here's a fact that you guys want to know. Did we write this down okay?
Yes.
Okay. If I ever have a proportion, really, two fractions, a over b equals now what? C over b. Because if you notice here, my denominators are what? These are the same. And like over here, my denominators are the same. All right, I want to give you guys a fact. This is kind of special. If we multiply both sides algebraically by b here, don't I get cancellation here and here?
Yes.
And so what that means is that our numerators are the same. So here's what I want to remark. If you have a fraction, actually you have a proportion. It's technically you have to have a proportion. And the denominators are the same. What that implies is this. We can write it this way. If a over b equals c over b, then a equals c. My numerators are the same. That's one thing we could look at. And now that's a really nice thing because that means in order to solve this equation here, so if I just say I got a piece of logic here, that means 3 then will be x plus 10. I get a nice linear equation, right, that we can solve in our sleep. Now, you say, how do I do that? Well, we're going to subtract 10 from both sides here. And then we end up, what's 3 minus 10? Negative 7 equals x, or we're going to say x is what? Negative 7. Here's your solution. X is negative 7. And then you might say to me, but is that really a solution here? Okay, so if we go back here and we check, right? Remember people said, oh, do I have to check? I say, yeah, check this. What do I say? Why do I say to check? Because what might happen here? This becomes 3 over what number? What's negative 7 plus 7? 0 equals, you just plugged in what here? Negative 7. What does that equal here? Well, it looks like it'll be 3 over what? 0. Now, what's the problem with this here? Yeah, you can't divide by 0 here, ladies and gentlemen. You could never divide by 0 because when you divide by 0, what does that mean? This is undefined. So what I have to do with this solution is simply what? I got to get rid of it. Because I could never divide by what? 0, ever. So if I get rid of that solution, what does that really mean for me then? Do you guys know what that means? There's no what? Solution here. Your solution set is what? Empty. So yes, checking is a valuable thing to do, and on occasion you're going to find that there's going to be no solution, and that's how we solve these. Okay? Number what? Number 12. What do we have? X over what?
X plus 5.
Okay, minus, what else?
5 over x minus 5.
And then what does that equal?
Equals 14 over x squared minus
Okay. Now, here's where we're starting to get to make things a bit interesting here, right? If you guys remember the LCM here, we're going to have to find the least common multiple of the terms in my denominator, right? X plus 5, x minus 5, x squared minus 5. But we went over this. We talked about this. We said this term down here we can factor as x plus 5 times what? X minus 5. Is that true? So when we went over this idea about how to find the least common multiple, we need x plus 5, that's our first term, x minus 5, x plus 5 now times x minus 5. That's the LCM. Well, I'm sorry, that's not the LCM. That's your terms here, right? It's a long Halloween. What did we say? How do you guys want to think of this again? We went through this one. Yeah, we can say, if you want, to notice a couple of things here. This term was prime. This term is prime. Is that right? And this is a product of those two prime terms. So when we talked about it this morning, I mentioned to you guys, maybe you want to do what? Think of this as really W, Z, and WZ, because they're analogous. And so when we talked about it earlier, we can say, because this is not factorable, it's prime. Not factorable, it's prime. And this is just a product of those two same factors, right? Are those terms. So can we do the procedure a lot easier with this? The answer is what? Yes. Give me a prime that goes into at least two of these terms. You're going to say what now? What are you guys going to say? Anybody know? What prime goes into W, Z, or W times Z? What term? We did this one earlier. It's going to be what? You're going to try maybe what, W? W goes into W. What's the quotient? 1. Does W go into Z? So bring it down. Does W go into WZ? Remember this? We said WZ divided by W gives you what? That's the Z. Good. Repeat your what? Process again, right? So give me a prime that goes into now at least two of these terms. What are you guys going to say? Z. Good. Does Z go into 1? No. Bring down the 1. Does Z go into the Z? Yes. Z divided by Z is what again? 1. And does Z go into Z? Yes. 1. What do you guys notice? Can you repeat this process? The answer is what? No. So what's this LCM going to be? You're going to say it's going to be W times Z times 1 times 1 times 1. Or you say this is what? Just that WZ. Is that right? However, we don't have W and Z. What do we really have? Yeah, we have this x plus 5, x minus 5, and then we have the product of those two. So what is this really analogous in saying? This means our LCM is what?
X plus 5 times x minus 5.
Outstanding. And that's a big deal, ladies and gentlemen, because people make a mistake right here. But it's very simple. If you think of it the way we went through it here, okay, if it's just single term variables that are not factorable, that are prime, that now makes this a lot easier. The stuff in gray is what I'm saying, right? So now my LCM will be that WZ, which is analogous to what you see down here and here. Okay, that's kind of the point I wanted to make earlier with these. So when you actually now have to go back with this equation here, right? Let's write it all down. That's what? X over x plus 5 minus 5 over x minus 5. What does that equal? Yeah, 14 over x plus 5 times what? X minus 5. What do I do with this again? Multiply by the LCM of x plus 5 times x minus 5. X plus 5 times x minus 5. Okay, don't forget to what? Distribute. And when we distribute, that just means your LCM is multiplied to every single term. So you should see it this way. X plus 5 times x minus 5 times x over x plus 5 minus x plus 5 times x minus 5 times 5 over x minus 5. 14 x plus 5 times x minus 5 over x plus 5 times x minus 5. What happens with this now? Yep, we got cancellation, right? If we did this correct, so double check here. My LCM was in fact multiplied to every term. So, cancel now. What could you cancel here? X plus 5s. What about over here? And what about here? Both terms, right? So what are you going to end up with that now? X times x minus 5 minus 5 times x plus 5. Good. And that's going to equal 14. So if we distribute now, again, both of these cases, you end up now with what? X squared minus 5x minus. That equals what? What could you do with this? X squared minus 10x minus what? 25 is 14. Does anybody know what kind of equation this is? These are some nice what? Quadratic equations. How do you solve them? Well, it has to equal 0. So you'll have x squared minus 10x minus, what's this? Is that 39 equals 0? So how do you guys solve quadratics again? You solve them how? Hopefully you can do what again? You can factor and then you use the zero product rule. Is that right? So when you factor now, x, what do you guys get? Do you guys remember this procedure? Back again from high school? My product has to be 39, right? I need two numbers. The sum is negative 10. 13 times 3. Which one is negative?
13.
Is that negative? Let's double check. What's negative 13 times positive 3? Is that negative 39? I think it is. What's negative 13 plus 3? Is that negative 10? You guys are right. Those are the numbers here. Good. Okay, zero product rule. What does that say now? X minus 13 is 0. X plus 3 is 0. How do you solve these again? Add 13 to both sides. Subtract 3 to both sides here, and you end up with x being what? 13, and x is going to be negative what? 3. Positive 13 and what? Negative 3. Now let's go back to the original equation here. What do we know that x can't be here? If you guys take a look at this situation here. What's going to make this undefined? Do you guys know what two values of x? We know x can't be negative 5, right? And we know what? x can't be positive 5. So you may want to go back and check your solutions to double check. But I just want to give you guys that hint. What does that leave us to? What number's next? 13. Good. We have a few more, and then we could give you back your test, and we can get out of here, I guess. Since I've been torturing you all this time. Right? It's fun for me, by the way. This is amazing fun for me. Yeah, geez. God, I don't know about you guys. I have so much fun every day. Is that terrible to have fun? Huh? You guys are waiting to leave? What do you mean? I could do this again. I could start all over. And I'm the one standing, and you guys get to sit. Huh?
Your commute is shorter.
I'm shorter? Is that right? Oh, my commute is shorter. Good. I hope you guys aren't coming from like Moreno Valley or something. You guys know what I mean? What number is this?
4, 13.
We're at number what? All right, it's just starting to get interesting. All right, what's number 13?
4 over x minus 3.
4 over x minus 3. What else?
Plus 2x.
Plus 2x over?
X minus 3.
Oh, okay. What does that equal?
12.
12 over?
X squared minus 6x plus 9.
I see. Okay, you guys. We're almost there. Look at this. So we need the LCM of our denominators, x minus 3, and x squared plus minus 6x plus 9 here. Now, always factor. This is x, what? Is that x minus 3 minus 3? So it's x minus 3 to the what? Second power. So I want to point this out to you guys. Make sure you factor those terms. Wherever it's factorable, you factor here. Because we now need to find the LCM if we look at the details. X minus 3 and really x minus 3 squared. Because do I need to list it twice? No. Okay. And then you might say, okay, Mr. Judge, how do you actually look at this if I have an x minus 3 that's not factorable? I look at it like if this is a prime number, like a w. Okay? And then this is w what? Squared. So we can do this a couple of ways. If you're awake, you're going to tell me the LCM is w squared. And if you tell me that, you're correct. Your LCM is, in fact, w squared. So what about now? What does that really mean here? What did I use to deduce this? Didn't I use the fact that it's always going to be, let me change this color, the variable to the what? Highest power. What's higher, 1 or 2? 2. Does that make some sense? So I can do it that way. Good, we covered that. Or, what could we do? Oh, guess what? If we go back here again, we have w. We got w squared. Give me a prime now that goes into both of these terms. You're going to say w. W divided by w is 1. And then w squared divided by w is w. Now repeat the process if you can. And you find, oh, you can't. And you're going to say, is my LCM going to be here again? W times 1 times w. And I'll say what? Yes, that's w what? Squared again. So this is the way we've been discussing even since the last section, right, of how you find the LCM. However, this is not the LCM of the question that we have. The LCM will be actually what? Go back here. It's going to be what? X minus 3 squared. Okay, so this is the LCM, is that right? Because that's our w squared. All right, you guys with me on that? You guys see the point there with that? So that makes this a lot easier to work with. For now, x minus 3 plus 2x over what? X minus 3. What does that equal? 12 over x minus 3 squared. I got to multiply the left side and the right side by the what? By the LCM of x minus 3 squared. And so notice I'm going to have to distribute here. And we should end up with x minus 3 squared times 4 over x minus 3 plus x minus 3 squared 2x over x minus 3 okay, is 12 times x minus 3 squared over x minus 3 squared. So notice again, my LCM is multiplied to what? Every term. And when that happens, how do we simplify? Do you guys know what's going on here? Cancels. What happens here? Cancels. What happens here? Cancels. We end up with x minus 3 times 4 plus 2x times x minus 3 equals 12. Okay, so distribute here so we can figure out what's going on. And what do we get now? 4x minus 12 plus 2x squared minus what? 6x is 12. Double check. Is that what you guys end up with?
Yes.
Yeah. Combine your like terms now, right? So you get 2x squared here minus 2x minus 12 equals 12. And we're going to add our 12 to both sides here. Is that true? Double check to see if everything I'm doing is correct here. 2x squared minus 2x, that equals what? 0. Is that true? Ah, that's why I have you guys double check. Thank you. Subtracting 12. That's going to change everything here. Good. So 2x squared minus what? 2x minus 24 is 0. So double check everything here, because you guys know I'm not awake and that coffee hasn't kicked in. All right, double check to see if my arithmetic is okay, because it's always never good to actually write and talk and think at the same time. So, all right, what do you guys do with this now? Remember this? What do you have to do with this? You have to factor, and they really mean factor completely. So the GCF of 2, 2, and 24, isn't that going to be what number? This is 2. My quotient is x squared minus x minus what? 12 equals 0. So now we have to factor what we call the quotient. Remember this? This is the quotient, and this is the GCF, because we're factoring completely. So 2x, x, go back to high school, I guess. My product is negative 12, right? What's my sum going to be? Negative 1 here. See, that's negative 1x. Two numbers multiplied together is negative 12, but when added is negative 1. What are the numbers? Is that negative 4 and 3? Is negative 4 times 3 negative 12? Is negative 4 plus 3 negative 1? Sure is. This is negative 4, and this is positive what? 3. Okay. So let me write this down here for you guys. 2 x minus 4, x plus 3 is 0. Now I want to point out to you guys, this implies here, remember, by the zero product rule, what this means is this term and this term are the only terms that can actually be 0, because 2 is not 0. And what that means is that x minus 4 is 0, or x plus 3 is 0. So I can add my 4 to both sides here. Subtract my 3. What do I get about x? X is 4, and x is what here? That's negative 3. Sometimes students don't like this. They say, Mr. Judge, can I divide both sides by 2 so that I get cancellation here? And I say yes. And then you obtain x minus 4 times x plus 3, and you know 0 divided by 2 is 0, right? You're running out of space here. So you could do that too. And that's going to be, by zero product rule, what you see. So x is 4, x is negative 3. You can go back and double check some of these things. And notice this. The only thing that we really have to be concerned with is that x can't be what number? Positive 3. So why can't x be positive 3? Because that'll make this, if I plug it in here, you now get 0 in the denominator, and you guys know you can never divide by 0. So anyway, you can try to double check those. This is now what number? 14. So what does 14 say?
5 over x plus 1
5 over x plus 1
plus 2x
plus 2x.
over x squared minus 1
Okay.
equals 1 over x plus 1.
Okay. Is that what you guys have in your? Is that one of the questions we had? Right. So you guys know the process again. We need what again? LCM of the denominators. But remember, you have to factor here. X plus 1, x minus 1. That's the difference of perfect squares. So our LCM again is x plus 1. And the other one is what? X plus 1, x minus 1. Do I have to include an additional x plus 1 again? Say no. Okay, you guys with me on that? If it's listed twice, we don't have to list it again. And if you're awake, what was this like? Right? This is not factorable. We can call that W. And then this is W times another non-fact. This is not factorable, right? This is W. They're the same terms. This is different. That's not factorable. Call that Z if you like. You with me on this? So we did these earlier too. So you can say, if I want to find the LCM of W and WZ, I want to go through that procedure here, right? By having a prime that divides, goes into both of these terms with a 0 remainder. What do you think that's going to be? Which prime would work? W, okay. What's W divided by W? What's W? Z divided by that W. This is my numerator, right? Numerator, this is the denominator. So I have WZ over W. What is that? Z, good. Can you repeat the process? No. What's the LCM going to be then? W times 1 times Z, or the LCM will be what? WZ. But really, your LCM will be what? X plus 1 times what? X minus 1. Okay, you guys okay with that? So that's what we're looking for. So I'm going to have to multiply every term by that. So I have 5 over x plus 1 plus 2x over x plus 1 times x minus 1. And then that's going to equal what? 1 over x plus 1. What do we multiply here by? X plus 1 times what? X minus 1. To the left side and to the what? Right side. So when I distribute, what happens? Yeah, we get now what? X plus 1, x minus 1 times 5 out of x plus 1 times, let's be careful, x plus 1, x minus 1 times 2x over x plus 1 times x minus 1 equals x plus 1 times x minus 1 over x plus 1. Remember, this is your LCM, LCM, LCM. So double check to see if we did this okay, right? Now, what should happen again? Some nice cancellation. X plus 1, you're gone. Is that right? What else is gone? X plus 1 and, oh, x minus 1 right in here. Then over here we got x plus 1, x plus 1. So let me remind you guys here. What's left? Because we have to go back and be very careful to see after that cancellation what's left. And what do we see here? What do you have what's left? 5 times x plus 1 plus 2x is x minus 1. So you're now going to use what here? Distributive property. 5x minus 5 plus 2x is what? X minus 1. And combine like terms. 5x and 2x gives you 7x minus 5 is x minus 1. Right? Subtract your x from both sides and you get what? 6x minus 5 becomes negative 1. What do I do now with that? Add your 5 to both sides. Is that true? Is 6x 4? Divide both sides now by what? 6. And you get now what? 4, 6. That's 2 times 2. 2 times 3. They cancel. What's x going to be? 2/3. Here's your solution. No? Is that true?
Yes.
I don't know. I could be making mistakes. I can't even see by this time, right? I can't even actually see what I'm doing. I don't know if it's the sun or whatever, but or it's just old age and being blind or who knows what. But this is number 14. Let's think we're okay. Good. Number what now? What's 15? What's that last one say?
5 over x minus 3.
Good. You got what? 5 over x minus 3. What else?
30 over x squared minus 9 equals 1.
Okay. We need to multiply both sides by the LCM, but make sure your denominators are factored. So this is my LCM. Is that right? I'm sorry, this is my denominator. Let's figure out the LCM. Okay, you have what? X minus 3, x plus 3 times what? X minus 3. How about if we try it this way? Let's see if you guys have grown enough over the last 2 lectures regarding LCMs. Could you guys tell me what the LCM will be? Remember, both of these are, this is what? This is prime. This is not factorable. And this here is factorable. We factored it, but each one of these terms here are prime, right? Prime and what else? Prime. So give me a prime that divides at least 2 of those. What is it going to be? X minus 3. Is that right? Good. Now, what is this first x minus 3 divided by x minus 3? 1. What's this x plus 3, x minus 3, this numerator divided by this x minus 3? What is it going to be? X plus 3. Outstanding. Good. Now, can we repeat the process? What do you guys think? Can I repeat this process? No. That means we're what? Done. So that the LCM is simply x minus 3 times what? X plus 3. So this is what we get to multiply to both terms. Or I should say, really, the left side and the right side, not both terms, every term. All right. 5 over x minus 3 minus 30 over x minus 3 x plus 3 equals 1. So multiply the left side by x minus 3, x plus 3, and the right side by x minus 3, x plus 3. And don't forget, on the left, you have what again? Two terms. You have a difference here, right? So, what do we get when we do this? We get what? X minus 3, x plus 3 times 5, over x minus 3 minus 30 times x minus 3, x plus 3 over x minus 3, x plus 3 equals x minus 3 times x plus 3. So if you guys remember here, what happens now with this? Yeah, let's just make sure. My LCM gets multiplied to the first term, the second term, and the last term. So I did end up multiplying every term by this LCM. So your cancellation will occur now, right? Let's see what cancels. X minus 3, x minus 3. X minus 3, x minus 3, x plus 3, x plus 3. Let's be careful to see what is left. Okay, let's see what's left. What's left here? X plus 3 times 5. That's just the 30. And then I have a product here. So we have now what? 5 times x plus 3 minus 30 is x minus 3 times what? X plus 3. So what would you guys do with this now? What's the algebra here, right? We're gonna have to distribute here, and what do you guys do over here? You FOIL, is that true? So let's see what we get. 5x plus 15 minus 30 is x squared minus 9. Does anybody know why that's x squared minus 9? Right, because your O and I terms will cancel. Is that true? Yeah, you got a difference there of perfect squares. You factored that, by the way. X squared minus 9, this is what it was up here, right? Nothing changed. Just want to point that out to you guys. Their O and I terms will be canceled here. And you have a nice quadratic because of the fact that your highest power of your variable x is what? Is 2. Anyway, so you might say, what do I do? Well, let's simplify. 5x minus 15 is x squared minus 9. So let's make the left side what? Equal to 0. Negative 15 is x squared minus 5x minus 9. And then what do you do with that 15? Add it. And what do you end up with? 0 is x squared minus 5x. What's 15 minus 9? Plus 6. Or x squared minus 5x plus 6. This will equal what? 0. What do I do here? I what? Factor. So do you guys remember we spent some time factoring here? Yeah, the product has to be what? 6. And your sum has to be negative 5, right? So we have x. So what two numbers multiplied together is positive 6, but when added is negative 5? What are the numbers? Negative 3, negative 2, is that right? Negative times a negative is a positive. Is that true? And then if we add them, isn't that negative 5? Okay, so it's -3, -2. Good. Zero product rule. X minus 3 is 0. X minus 2 is 0. What do you guys do? Add 3. Add 2. What do you get for x? X is positive 3 here, and x is positive what? 2. Now, be careful here. Can x be positive 3 now? How do you guys know x can't be positive 3 here? See this? Yeah. If x is 3, you got 5 over 0. If it happens in only one fraction, you got to throw it out. Because 5 over 0 is undefined. Is that right? And what does that mean again? That means there's no definition. It's undefined. Anyway, we talked about that, right? So what that means here for us is we can't have what? 3 as a solution. Okay, could you have 2? If we said, let's go back and plug in 2 here. Let's just be careful here. You get 2 now. Is that right? And if I plug in down here 2 as well. I can plug it down here too. I think I like doing that better. Let me do some work up here. I know it looks weird, but okay. 5 over, what's 2 minus 3? Is that -1? Minus 30 over, what's this? 2 plus 3, isn't that 5 down here? 2 minus 3, is that -1? Should that be +1? Is that right? So, isn't this going to say -5 minus, take a look at the algebra here. Isn't that -5? 30 divided by -5 is what? What's this minus the minus? What does that give you? -5 plus 6. Is that going to be +1? True statement. So that means our only solution to this equation is going to be what? So I can put that in the solution set. So that's the only what solution here. Okay, hold on. And